Okay, let's look at this game as a one-time play, repeated play, and first mover advantage. Again, we are dealing with the Duopolist's dilemma, or prisoner's dilemma, right? Okay, we have from B with the payoffs in blue, we have from A with the payoffs in red. There are two strategies here. The first strategy is the 99 cents up. The second strategy is the $1.99 up. Now, what is the Nash equilibrium just looking at this game? It's this one. That's the Nash equilibrium. And what is the monopoly outcome? This is the monopoly outcome, or the collusion outcome, right? Okay, now remember what we said in class. The monopoly outcome or the collusion outcome is not a stable point. So take for instance, if from A believes that from B is going to stick with the 99 cents up, so if from B is only focused on this column, right, what will from A do? From A will be tempted to change their strategy from this 99 cents up to the $1.99 because they get 6 million, which is bigger than 1 million. So this tells you that this collusion outcome is not stable. Now, the same applies to from B, right? Let me just get some of these things out of our way. If from B knows that from A is going to stick with the collusion outcome, therefore play the 99 cents up, what would from B do? So what I'm saying is from A is going to stick with this row right here, right? What would from B do to react to that or in response to that? Well, from B will be tempted to change their strategy from the 99 cents up, which gives them the collusion outcome, to this $1.99 up because they get 5 million. You see, so both firms are incentivized to cheat on this monopoly outcome or to cheat on this collusion outcome. And so because they are both tempted to cheat, and they will cheat or they will deviate, they end up playing for this lesser outcome where they're both choosing the $1.99 up. Now, this lesser outcome, 250K, this is the Nash equilibrium. At 250K, neither of the firms are incentivized to cheat. I will show you that. So let's assume that from A will stick with their $1.99 up strategy. So this row right here with the arrow pointing to the row, do you see that? Okay. What will firm B do in response to that? Well, firm B will stick with $1.99 up. Now, is there any case where firm B would like to play the 99 cents up? No, because they get 120K, which is smaller than 250K. You see, so firm B would like to stay with the $1.99 up, which gives us the Nash equilibrium. Firm B would like to stay or stick with their $1.99 up, which gives them the Nash equilibrium with these payoffs that are smaller than the monopoly outcome. The same thing applies to firm B. Let's say firm B is taken with their $1.99 app strategy, which gives them the Nash equilibrium. Well, is there a case where firm A, in response to that, would like to play the 99-cent app? No. If firm A plays the 99-cent app, look at what they are going to get. 100K compared to 250. You see? So it's better for firm A, when firm B is using the $1.99 app, to also do the $1.99 app. So this is why we say that the Nash equilibrium is a stable point. Neither firm is incentivized to move or to deviate or to change their strategy. Okay. So when we play this game only one time, what is the equilibrium? Well, what is the Nash equilibrium? The Nash equilibrium is where both firms play their dominant strategy, where they both choose to play the $1.99 app strategy to get $2.50 each. You see? So pause the video and go back if you need to. So that is what happens when we play this game one time. What happens if we play this game repeatedly, right? So if we play this game for many years, that is firm A and firm B play this game for many years, or there is a repeated version of this game, what strategies would firm A and firm B choose? Well, like we saw in class, when this game is repeated, firms A and B would choose the monopoly outcome. This one. What? Yes. Now, here's what will happen. Both firms will play the 99-cent app strategy to get 1 million each. But there's a condition attached: as long as the other firm reciprocates. You see, the monopoly outcome is selected as long as the other firm reciprocates. So what happens when the other firm does not reciprocate? Well, that opens the door for the firm that deviates or cheats to be punished. And how is the firm punished? Well, the one who gets cheated on will stop playing this 99-cent app that gives them the monopoly outcome and go back to playing their dominant strategy. Yeah. But for the purposes of our class, remember that what you want to be concerned with here is both firms will play the 99-cent app, which gives them the monopoly outcome, as long as the other firm reciprocates that. Okay, good. And now we move to the first mover advantage. The first mover advantage is typically solved in a tree form. So we're going to take this payoff matrix or this table and convert it into a tree. Now, to get this video moving quickly, I converted the table into a tree. And this is where I would like you to pause the video and see if I did it right. Now, I'm going to quickly show you that when you're on this branch, where firm A and firm B are using their 99-cent app strategy, they will both net that 1 million each, right? Is that correct? Yes. So this is that payoff and those strategies that I converted into this arm of the tree. Okay, now this is where you pause and go look at the other arms, right? So there's this arm right here. There is this arm right there. So there are 4 branches here or arms here. And there's this one. And now my tree is messy, so I have to prune it a bit. Like clean some of these off. That way we can get our work done. Okay. Now, how do you solve first mover advantage games? Or first mover advantage category games. Now, we solve this tree game using the backward induction. So we are going to start at the ends of the game and move to the top. Now the first mover will sit at the top of the game, and the second mover will sit in the middle of the game, and the payoffs will be at the end of the game like this. So yes, we are assuming that from A is the first mover. Okay, cool. That said, how do we solve the game? Well, first you consider firm B, so the firm in the middle, you consider firm B's dominant strategy, and then you check firm A's reaction to firm B's dominant strategy, right? So how to solve this game? Let me write that out for us. How to solve. Find firm B's strategy. Oh, firm B's dominant strategy. And then 2, check firm A's reaction to firm B's dominant strategy. Okay, so let's go and check what firm B's dominant strategy is. Now, firm A has 2 strategies. Firm B also has 2 strategies. But in oligopoly, there is this feature called mutual interdependence, meaning firm B will always consider firm A's behavior as it makes its own decisions. So firm B is not going to make decisions independent of firm A. It's going to take firm B's potential reactions into consideration when it is trying to think through its own actions and therefore decisions it has to make. Okay, so firm B is speculating that firm A would do the 99 cents up. So we are here. What would firm B do? Look at the blue, the payoffs in blue. The bigger one is right here. So firm B would use the $1.99 up strategy if it believes that firm A will use the 99 cents strategy. Do you see that? Okay, let me change color real quick. Let's use yellow. Now, if firm B believes that firm A will use the $1.99 up strategy, then what should firm B do? Look down here to see the payoffs in blue, right? This one is bigger. So firm B, if it believes firm A will use the $1.99 up, firm B should use the $1.99 up. So it looks like firm B's dominant strategy is the $1.99 up, right? So the answer here is $1.99 up. So now we need to check firm A's reaction to firm B's dominant strategy. Now firm A gets to move, and it will choose between these two these two payoffs that I have put in these boxes. Do you see that? Okay. Should firm A use the 99 app strategy or the $1.99 app strategy? Look at the payoffs in red in the boxes. This one is bigger. 250K is bigger. And so firm A will do the $1.99 app strategy. You see? So, okay, in green here we say, or how do you write this up? Well, firm B's dominant strategy is the $1.99 app, and firm A reacts to firm B's dominant strategy by choosing the $1.99 app strategy as well, so that they end up both getting 250K as their payoffs. Pause the video, go back and take a look. Okay, so what if we flip all of this and make firm B the first mover and firm A is the second mover? Would the results change? Well, first, the way we solve this is again by backward induction. So we will, how to solve? Let's pick blue. How to solve? You got it. Well, find firm A's, right? Because firm A is now in the middle. It's not the first mover. Find firm A's dominant strategy. And then check firm B's reaction to it. Okay, so here we go. If firm A believes that firm B will do the 99-cent strategy, and let me go back to yellow because I have blue everywhere already. If firm A believes that firm B would do the 99-cent app, what should firm A do? Look at the payoffs in red right here and right here. What should firm A do? Yeah, firm A should do this one, the $1.99 app, because 6 million is bigger than 1 million. Okay, if firm B believes, if firm A believes, because firm A is not the first mover anymore, and we are solving this by backward induction. So if firm A believes that firm B will do the $1.99 app, what should firm A do? Well, look at the payoffs in red. 250K is bigger than 100K. So this one. Now, firm B gets to move in reaction to what it thinks is firm A's dominant strategy. Right? So, okay. Should firm B do the 99-cent app or the $1.99 app? Just look at the payoffs that I put in these boxes right here. What should firm B do? Definitely firm B should do $1.99 because 250K is bigger than 120K. Okay, I hope this helps clear things up. It's much better to put these into the tree form because then things are easier. In the box form, as we saw in class, they are not in different colors. It's very difficult to distinguish the payoffs, the A's and the B's and the 99 cents and the $1.99. But anyway, this was a fun example, and so I hope it helps you. Have a good one. Dr. T out. Did you like that?